In this video, I want to talk about a few more things that come along with implications. So if you haven't yet, read through this section of our text. You might also want to watch this previous video on implications because I'll sort of keep using this example that I used up there. So once we learn about implications, we get these two ways to change an implication, right? So if P implies Q is the implication, then the converse would be Q implies P, switching the order. P implies Q. We could also change this into the statement not Q implies not P. So when we talked about this first video, I talked about how the operation is not commutative. So what we're really doing here is comparing the implication and its converse. Q implies P. In the example up here, Q implies P was if I pay $5, then I cross the Mackinac Bridge. And we talked through why that's clearly false, right? I can pay $5 and not cross the Mackinac Bridge. There's no cause and effect relationship there. So the converse doesn't always have the same truth value as the implication itself. So P implies Q is not always equivalent to Q implies P. They're not equivalent statements. However, the contrapositive is an equivalent statement. P implies Q, equivalent to not Q implies not P. So this is interesting. We have two equivalent statements that are both implications, but a different way of writing it and expressing it. Now you might wonder why we would care about the contrapositive of an implication. And we'll see later on, sometimes when we're proving something, let's say we want to prove that an implication is true. We have some implication in mind. We want to prove it's true. Sometimes it's very difficult to show that directly, to assume that P is true and then show that Q has to follow from that the cause-effect relationship holds. Sometimes it's easier, and it depends on the situation, sometimes it's easier to think about the implication instead as its contrapositive, which ends up being easier to show is true, that not Q implies not P, that cause-effect relationship is true. The two cause-effect relationships are entirely equivalent to each other, is what this statement is saying, and so it doesn't matter which one I use, and so this offers a proof technique that we'll see called proof by contrapositive. Instead of looking at it directly, we look at the contrapositive. So this converse idea is important, right? Converse isn't necessarily the same as the implication, but the contrapositive is. So going up with this example, if I cross the Mackinac Bridge, then I pay $5. Going along with this, what's the contrapositive in this case? Not Q implies not P. So Q was I pay $5. So this would be I do not pay $5. $5. So that's an implication. I say if I do not pay $5, then P was I cross the Mackinac Bridge. So this would be then I do not cross the Mackinac Bridge. So the claim is that this is the same as P implies Q. If I cross the Mackinac Bridge, then I pay $5. So right, what this implication is saying again is if I'm going up here and I try and cross the Mackinac Bridge, I have to pay $5. Another way of saying this is if I don't pay $5, then there's no way I could cross the Mackinac Bridge, right? The toll booth is enforcing it. They're preventing that from happening. They would stop me, and if I tried to cross without paying the $5, some policemen would come after me. Some state troopers would be after me. So they're enforcing that implication is true, and they're really doing it in a way by the contrapositive, or at least there's another way to think about it, is they're preventing cars that do not pay $5 from crossing the Mackinac Bridge. If I do not pay $5, I do not cross the Mackinac Bridge is a true statement just because P implies Q is true. So that's converse and contrapositive. We'll see those come up quite a bit.